Since the dawn of time, the night sky has stretched above, a boundless tapestry of darkness and light, inviting endless wonder. The cosmos unfolds in every direction, a silent expanse where time and distance lose all familiar meaning. The moon glows with ancient light, and the stars shimmer like scattered jewels, each one a distant sun adrift in the infinite ocean of space. Their presence hints at mysteries far beyond the reach of sight or imagination. Our world is but a single grain of sand upon a cosmic shore, circling an ordinary star, itself one among hundreds of billions in a swirling galaxy. Beyond, galaxies gather in clusters, each a sprawling city of stars, stretching outward with no end in sight. In the deepest images captured by telescopes, every pinpoint of light is not just a star, but an entire galaxy, vast islands of brilliance, each containing billions of suns drifting through the cosmic sea. The scale of the universe is staggering, a cascade of distances and numbers that defy comprehension. Infinity here is not a number but a concept, an endlessness that stretches beyond the limits of thought. To gaze into the cosmos is to peer into a bottomless well, where every glance reveals new depths and every discovery opens doors to further mysteries. The universe beckons with its spiraling galaxies and glowing nebulae, each a masterpiece painted on the canvas of eternity. It is a realm where time flows differently, and distances are measured in the lifetimes of stars. Does the universe have an edge? Or does it extend forever, a boundless expanse with no horizon? The question lingers, echoing through the silence of space. Within swirling clouds of gas and dust, new stars ignite, their light joining the endless symphony of the cosmos. Every atom, every spark is a note in the infinite song of creation. Patterns emerge in the darkness, constellations drawn by chance and physics, their forms shifting over eons as the universe evolves. Across the void, vessels of metal and light journey outward, seeking to touch the infinite, to measure the immeasurable. Instruments of glass and steel reach for the stars, gathering ancient photons that have travelled for billions of years, revealing secrets written in the language of light. Radio waves and cosmic signals whisper across the void, carrying echoes from the dawn of time, mapping the uncharted realms of space. Each discovery is a piece of a vast puzzle, fitting together to reveal a universe that may have no boundaries, no final edge, only endless possibility. The universe is not merely a distant spectacle, it is the infinite stage upon which all matter and energy dance, forever unfolding, forever infinite. To truly grasp the nature of what might exist beyond, it is essential to first examine the observable universe in depth, its boundaries, its structure, and the scientific principles that define what we can know. The observable universe is not enclosed by a physical barrier, but by a horizon determined by the speed of light and the finite age of the cosmos. This horizon marks the maximum distance from which light or any signal has had time to reach us since the universe's origin. This cosmic horizon is analogous to standing at the edge of a vast ocean, where the limit of vision is not the end of the ocean itself, but simply the farthest point visible from a given vantage. The speed of light, approximately 299,792 kilometers per second, acts as a universal speed limit. Because of this, the light from distant galaxies takes billions of years to reach us, so we observe them not as they are now, but as they were in the distant past. The universe is estimated to be about 13.8 billion years old. However, due to the expansion of space itself, the edge of the observable universe is much farther than 13.8 billion light-years, currently calculated to be about 46.5 billion light-years in every direction, making the observable universe roughly 93 billion light-years in diameter. This edge is not a spatial boundary, but a temporal one. It represents the limit set by the age of the universe and the time it takes for light to travel, rather than a physical edge in space. Beyond this horizon, there may be countless galaxies and cosmic structures, but their light has not yet had time to reach us, rendering them forever invisible with current technology and physical laws. The observable universe forms a vast luminous bubble, centered on the observer, filled with billions of galaxies, each containing billions of stars, all bound within the limits set by the speed of light and cosmic time. Scientific reasoning and cosmological models suggest that the universe likely extends far beyond this observable bubble, possibly infinitely, though this remains an open question in modern physics. The observable universe is only a portion of the whole, its limits defined not by the extent of space, but by the reach of light and the passage of time since the Big Bang. Within this region, astronomers use a variety of scientific methods to probe its structure and history. Observations of electromagnetic radiation, visible light, radio waves, X-rays and more allow the mapping of galaxies, the measurement of cosmic expansion, and the study of the universe's earliest moments. The cosmic microwave background, a faint afterglow from the Big Bang, forms the most distant observable light, providing a snapshot of the universe when it was just 380,000 years old. Beyond the observable universe, the nature of reality remains unknown. It could be filled with more galaxies and familiar structures, or it could contain phenomena utterly unlike anything within the observable region. The observable universe, with its immense scale and complexity, serves as both a window and a limit, revealing the grandeur of the cosmos while reminding us of the boundaries imposed by physics. Scientific inquiry continues to push these boundaries, using ever more sensitive instruments and innovative techniques to extend the reach of observation and deepen understanding. The universe may be far larger, more complex and more mysterious than the observable region reveals, its true extent and nature still awaiting discovery through the relentless pursuit of knowledge. What mysteries unfold beyond the edge of our observable universe? At this boundary, the known laws of physics meet the vast unknown, and speculation becomes a tool for discovery. One prevailing theory suggests the universe is truly infinite. Beyond the cosmic horizon, the same tapestry of galaxies, nebulae, and dark matter continues without end, repeating cosmic structures in an endless expanse. In this scenario, every possible arrangement of matter could exist somewhere, with clusters of galaxies and planetary systems forming patterns both familiar and alien scattered across the infinite void. Another profound idea is the multiverse hypothesis. Here, the universe is but one bubble in a vast cosmic foam, each bubble a separate universe with its own unique set of physical laws, constants and dimensions. Some of these universes may be dominated by darkness and entropy, while others burst with exotic forms of energy and matter, governed by forces and particles unknown to our own universe. Within this cosmic sea, certain universes might achieve a delicate balance, allowing for the emergence of complex structures, while others remain in perpetual chaos or perfect symmetry. The concept of cosmic inflation further expands these possibilities. In the earliest moments, space itself underwent a rapid exponential expansion, stretching quantum fluctuations to cosmic scales. This process may have spawned countless isolated regions, each evolving into its own universe. As a result, vast domains of space are receding from each other at speeds exceeding that of light, forever separating their contents and rendering them inaccessible, lost to the darkness beyond the cosmic horizon. These ideas are rooted in the mathematics of general relativity and quantum field theory, where the fabric of space and time is shaped by energy and the quantum vacuum seethes with potential. Such theories help explain the remarkable uniformity and flatness observed in the cosmic microwave background, suggesting a universe shaped by forces beyond direct observation. Though these realms remain beyond empirical reach, they invite contemplation of dimensions, topologies, and realities that defy conventional understanding. The universe beyond our sight could be a seamless extension of the familiar or a branching network of infinite possibilities, each branch a distinct reality governed by its own rules. Every theory, from the infinite cosmos to the multiverse, challenges the boundaries of what can be conceived, urging a reimagining of existence itself. The unknown stretches endlessly, a cosmic invitation to explore the profound depths of possibility, where reality itself may be but one thread in an infinite tapestry. To truly grasp what may exist beyond the observable universe, we must turn to both advanced scientific theories and deep philosophical inquiry. Let's explore these concepts through detailed metaphors and rigorous ideas. Imagine the universe as a balloon, its surface dotted with galaxies. This is the classic analogy for cosmic expansion, rooted in general relativity. The balloon's surface represents all of space, and as it inflates, every galaxy moves away from every other, illustrating Hubble's law and the absence of a central point. As the balloon expands, the distances between galaxies increase uniformly, reflecting the metric expansion of space itself. This model, however, is limited to the observable universe. What lies beyond its surface remains a profound mystery. In reality, the universe expands everywhere at once with no edge or center. This is a consequence of the cosmological principle. On large scales, the universe is homogeneous and isotropic, yet what exists beyond this uniformity is unknown. To contemplate the multiverse, envision a foam of soap bubbles. Each bubble is a separate universe, possibly governed by different physical laws or constants. This is the landscape of eternal inflation, where quantum fluctuations spawn countless universes beyond our own cosmic horizon. From within a single bubble, the others are inaccessible, separated by vast stretches of inflating space or even by different dimensions. The boundaries between universes may be absolute, or perhaps in some theories they could interact through quantum entanglement or higher dimensional bridges. Infinity itself is a concept that challenges both mathematics and philosophy. Imagine a straight line that never ends, or a space that stretches without boundary in every direction. In some cosmological models, the universe is spatially infinite, containing endless matter and energy. In an infinite cosmos, every possible configuration of matter could exist somewhere, including infinite versions of familiar worlds. This leads to the philosophical idea of the cosmic doppelganger, an infinite repetition of patterns, histories, and even conscious experience. These metaphors, while simplified, are grounded in complex mathematics, general relativity, quantum field theory, and the principles of cosmology. They serve as bridges between abstract equations and the vast, unobservable realities they describe. Through these models, science takes its first steps toward understanding realms that may forever lie beyond direct observation. They invite us to question the limits of knowledge and the nature of existence itself. Theories such as string theory, loop quantum gravity, and the holographic principle attempt to weave together the fabric of space, time, and information, suggesting that what we perceive as reality may be a projection from deeper, more fundamental layers. The true nature of the cosmos is likely more intricate and beautiful than any metaphor or model can capture. Its complexity hints at structures and dimensions far beyond current understanding. Yet, these conceptual images are essential. They spark inquiry and frame the questions that drive both science and philosophy. They connect the pursuit of knowledge to the deepest mysteries. What is reality? What lies beyond the observable? Is infinity a physical truth or a mathematical abstraction? The journey to comprehend the infinite is ongoing, each theory and metaphor a stepping stone toward greater understanding. Every model, every idea brings us incrementally closer to unraveling the profound enigma of what lies beyond the known universe. Infinity stands as a monumental concept in both mathematics and physics, a value that surpasses all others, a quantity without end, and a possible reality within the fabric of the cosmos itself. In mathematics, infinity is not a number in the traditional sense, but a symbol representing unboundedness. It appears in calculus as a limit, in set theory as the cardinality of endless sets, and in geometry as the point where parallel lines meet at infinity. In physics, infinity often emerges at the edges of understanding, where equations break down and known laws no longer apply. The notion that space itself might have no boundary defies the logic of finite systems, which are defined by edges, borders, and limits. In the cosmos, the absence of a boundary means there is no edge to cross, no final frontier to reach. The universe, in this sense, becomes a set with no outer limit, a continuum extending endlessly in all directions, with no centre and no edge. When mathematical equations yield infinity, such as at the singularity of a black hole, it signals a breakdown in current physical theories. Here, density and curvature of space-time become infinite, indicating that the known laws of physics are incomplete. At the core of a black hole, gravity compresses matter to a point of infinite density, a singularity where general relativity ceases to function and quantum gravity is required to describe reality. The universe itself may be infinite in extent, containing an unending expanse of galaxies, stars, and cosmic structures with no boundary to enclose them. Observational measurements indicate that space is flat on the largest scales, analogous to a two-dimensional plane where parallel lines never intersect, no matter how far they are extended. In such a flat, ever-expanding universe, the cosmos is likely infinite, with galaxies receding from one another as space itself stretches without end. The observable universe is merely a finite region within this infinite expanse, defined by the distance light has travelled since the beginning of cosmic time. All that can be detected and measured is but a minuscule portion of the whole, like a single grain of sand within an immeasurable desert. The realization of cosmic infinity transforms the understanding of scale, rendering all finite measurements insignificant compared to the boundless totality. Infinity in the cosmos means that space is not a closed system, but an open continuum, an unending expanse with no final boundary. This continuum stretches on without limit, filled with phenomena and structures that may never be fully catalogued or comprehended. The mathematical concept of infinity, when applied to the universe, alters the framework of understanding, introducing endless possibilities and unbounded complexity. The endlessness of the universe remains both a profound mystery and an open invitation to further exploration, forever beyond complete measurement or comprehension. Black holes are among the most enigmatic and powerful objects in the cosmos, regions where gravity is so intense that nothing, not even light, can escape their grasp. These cosmic phenomena are born from the catastrophic collapse of massive stars, compressing matter into an unimaginably small space. At the heart of every black hole lies a singularity, a point of infinite density where the known laws of physics cease to function. Surrounding this singularity is the event horizon, a boundary beyond which nothing can return. The immense gravitational pull warps space and time, distorting the very fabric of the universe. Once considered purely theoretical, black holes have now been observed indirectly through their effects on nearby matter and the bending of light. In recent years, astronomers have even captured images of their shadows, revealing the dark silhouette cast against glowing cosmic gas. The mysteries of black holes have inspired theories about cosmic tunnels known as wormholes. These hypothetical structures, predicted by Einstein's equations, could act as shortcuts through space-time, connecting distant regions of the universe, or even different universes entirely. Wormholes, also called Einstein-Rosen bridges, are theoretical passages through space-time. Their existence would require exotic matter with negative energy to keep them stable and open, substances that have yet to be discovered or understood. If real, wormholes could revolutionize our understanding of travel and connectivity in the universe. Black holes themselves are not just destructive forces, they are also engines of creation, shaping galaxies and generating powerful jets of energy. Their mergers send gravitational waves rippling across the cosmos, offering new ways to observe the universe. The true nature of black holes, wormholes, and cosmic tunnels remains one of the greatest puzzles in astrophysics. These phenomena challenge our understanding of space, time, and the fundamental laws that govern reality. Black holes and cosmic tunnels stand as symbols of the universe's deepest secrets, enigmatic frontiers that beckon with unanswered questions and the promise of discovery. What compels the cosmos to be explored? Its mysteries unraveled, its secrets brought to light? There exists an insatiable drive, a force that seeks to illuminate the unknown, to pierce the darkness with understanding. Curiosity is the engine of discovery, a relentless urge that propels the search for meaning amid the vastness of space. From the careful study of distant galaxies to the creative interpretation of cosmic phenomena, every discipline is drawn to the universe's grandeur. The universe reveals its story through swirling nebulae, the birth and death of stars, and the intricate dance of galaxies, each image a chapter in the cosmic narrative. Every discovery is a new piece in an ever-expanding puzzle, shifting the boundaries of what is known and inviting deeper questions. The realization that no single world holds the center of existence brings humility, yet also opens the way to a broader, more profound understanding. As the concept of infinity and the possibility of countless universes emerge, the scope of inquiry expands beyond measure. The pursuit of cosmic knowledge weaves a tapestry that transcends boundaries, connecting all forms of inquiry in a shared quest. This journey is a testament to the power of collective curiosity, reaching ever outward, striving to touch the stars themselves. The cosmic story is one of endless seeking, a perpetual voyage toward greater understanding, forever driven by the desire to know more. Across the vastness of the cosmos, questions shimmer like distant stars, eternal, elusive, and perhaps forever beyond the reach of certainty. Is the universe truly infinite, or does it curve back upon itself in ways unfathomable? Do realms beyond our own parallel universes pulse with their own laws and wonders, forever hidden behind the veil of cosmic silence? The cosmic horizon stands as a silent boundary, a luminous edge where knowledge dissolves into the unknown, and the observable universe surrenders to infinite possibility. This is not a failure of exploration, but a profound acknowledgement of the universe's grandeur, a recognition that the finite can only ever glimpse the infinite, and that the cosmos is not obliged to yield all its secrets. Within this mystery lies a beauty beyond measure. The unanswered questions are not voids, but luminous invitations, beckoning curiosity, igniting wonder, and inspiring the ceaseless pursuit of understanding. If every secret were revealed, the universe would be stripped of its poetry, its magic dissolved into mere certainty. The unknown is the wellspring of awe. Science is not a static ledger of facts, but a living process, a dance of questions and revelations, each answer unfurling new mysteries in its wake. Consider dark matter and dark energy, invisible architects shaping the cosmos, their presence inferred yet their nature concealed. They compose the majority of existence, yet remain enigmatic, challenging the limits of comprehension. The journey through the unknown is itself the purpose. The act of seeking, of questioning, is the heartbeat of cosmic discovery. Instruments gaze outward, not to conquer mystery, but to deepen the dialogue between the known and the unknowable, enriching the cosmic tapestry with every observation. The universe offers no promises of answers, only the profound privilege to ask, to wonder, and to marvel at the questions themselves. This opportunity to ponder, to explore, to be awed by the unknown is the greatest gift the cosmos bestows. The infinite mystery is an endless well of inspiration, a cosmic muse that stirs the imagination and propels the quest for understanding ever onward. And so the search continues, an eternal voyage through the boundless, beautiful unknown. In the vast, silent expanse of the cosmos, where galaxies drift like islands in an endless ocean of darkness, the infinite stretches beyond the reach of imagination. Here in the boundless void, stars are born and die in cycles that span billions of years, their light travelling across unimaginable distances, weaving the fabric of reality itself. Every swirling galaxy, every luminous nebula, every silent black hole is a testament to the universe's relentless creativity and its unfathomable scale. The cosmos is a place of both violent transformation and serene beauty, where the laws of physics sculpt wonders beyond comprehension. In this grand tapestry, patterns emerge and dissolve, from the delicate filaments of interstellar dust to the radiant arcs of auroras on alien worlds. The infinite is not empty, but alive with phenomena that challenge the limits of understanding. The universe's architecture is a masterpiece of complexity, with galaxies bound together by invisible threads and gravity bending the very path of light. Each discovery reveals deeper mysteries, inviting endless curiosity. The infinite journey through space is a journey through wonder itself. Pulsars beat like cosmic hearts, quasars blaze with ancient energy, and the unseen presence of dark matter shapes the destiny of galaxies. The story of the cosmos is written in the language of time and energy, from the first flicker of starlight in primordial darkness to the ever-expanding horizon of the universe. Each epoch is a chapter in an endless narrative, echoing with the possibility of what lies beyond. The infinite is not merely a measure of distance or time, but a wellspring of awe. It is the spiral of galaxies, the birth of worlds, the silent drift of comets in the outer reaches of space. To contemplate the infinite is to stand at the edge of knowledge, humbled by the grandeur of existence. The universe offers no final answers, only deeper questions, and in this endless search, wonder itself becomes the destination. The infinite awaits, not as a place to be conquered, but as a mystery to be revered. Its beauty is in its vastness, its meaning in its unknowability. In seeking to understand the universe, we encounter the sublime, an endless journey through cosmic wonder, where every discovery is a reminder of the profound and beautiful mystery that is the infinite. Imagine for a moment that our universe is not the only one. Beyond the cosmic horizon, past the limits of our observation, there may exist a multitude of universes, an endless ensemble known as the multiverse. Each universe, or bubble, could have its own unique laws of physics, its own dimensions, and its own tapestry of galaxies, stars, and cosmic wonders. The simplest kind of multiverse is the bubble multiverse. Here, our universe is just one bubble in a vast cosmic foam, each bubble expanding and evolving in its own way. In some bubbles, gravity might be stronger, stars might burn blue or never ignite at all, and the very fabric of reality could ripple with unfamiliar energies. Then there is the many worlds interpretation, where every quantum event branches into countless new realities. In this scenario, every possibility becomes real. Each choice, each cosmic event spawns a new universe, diverging endlessly. Somewhere perhaps a supernova never erupted or a galaxy formed in a different corner of space-time. Other theories propose a brain multiverse, where our universe is a three-dimensional surface, like a membrane, floating in a higher dimensional space. Parallel universes could drift alongside ours, separated by imperceptible gaps, occasionally colliding and giving birth to cosmic phenomena beyond our understanding. There is also the concept of mathematical universes, where every consistent set of mathematical rules gives rise to its own reality. These universes may be so alien that even the idea of space and time is unrecognizable, governed by laws we cannot even imagine. The implications of the multiverse are profound. If infinite universes exist, then every conceivable version of reality may play out somewhere. The laws of chance and necessity stretch beyond our comprehension, and the meaning of everything expands to unimaginable scales. Yet, the multiverse remains a hypothesis, a grand idea at the edge of scientific imagination. No telescope can yet peer across the boundaries of universes, and no experiment has glimpsed their shadows. Still, the concept stirs the deepest sense of wonder. It dares us to consider a cosmos without boundaries, where reality itself is infinite in variation and possibility. In contemplating the multiverse, we are reminded that the universe we know may be just one thread in a boundless cosmic tapestry. Each universe, mysterious and majestic in its own right, adds to the grandeur of existence. The multiverse is not just a theory, it is a testament to imagination, a vision of endless creation where the infinite truly knows no bounds. Invisible forces shape the cosmos in ways both subtle and profound. Among the deepest mysteries of our universe are two unseen players, dark matter and dark energy. Though they remain undetectable by ordinary means, their influence is felt everywhere, guiding galaxies, sculpting cosmic webs and accelerating the very expansion of space itself. Let us first journey into the realm of dark matter. Unlike ordinary matter, the atoms and particles that build stars, planets, and nebulae, dark matter does not emit, absorb, or reflect light. It is utterly invisible, revealed only by its gravitational pull. When astronomers observe galaxies spinning, they notice something perplexing. The outer stars orbit far faster than visible mass alone can explain. Only a hidden halo of dark matter, outweighing all visible stars combined, can account for this cosmic choreography. Vast filaments of dark matter thread through the universe, forming a skeleton upon which galaxies and clusters assemble. Without this unseen scaffolding, the universe would lack the structure we observe. The grand spiral arms, the elegant clusters, the intricate cosmic web. Yet despite decades of searching, the true nature of dark matter remains elusive. Is it made of undiscovered particles, such as WIMPs or axions? Or could it be a sign that our understanding of gravity itself needs to be rewritten? The answers for now lie in the shadows. But the universe holds yet another, even more enigmatic force, dark energy. This mysterious presence is not only invisible, it is everywhere, woven into the very fabric of space. In the late 1990s, astronomers made a startling discovery. The expansion of the universe is not slowing down, as once believed, but speeding up. Galaxies are racing away from each other at an ever-increasing pace, propelled by an unknown energy that fills all of space. Dark energy now dominates the cosmos, accounting for nearly 70% of all its contents. Its nature is hotly debated. Some theories suggest it is a property of space itself, a cosmological constant that Einstein once imagined. Others propose it is a dynamic, evolving field, changing over cosmic time. Some speculate it could be a sign of extra dimensions or a hint at new physics waiting to be uncovered. Together, dark matter and dark energy shape the destiny of the universe. They decide whether it will expand forever, tear itself apart, or one day collapse back into darkness. Yet for all their power, they remain unseen and unexplained, cosmic riddles at the heart of reality. Even without direct evidence, their presence is woven into every observation, every theory, every map of the heavens. The universe, it seems, is far stranger than our senses alone can reveal. As we peer deeper into the cosmos, the mysteries of dark matter and dark energy remind us that much of existence lies beyond the reach of light, hidden in shadows and silence, waiting to be understood. In the moments after the Big Bang, the universe underwent a transformation more dramatic than anything since, a phenomenon known as cosmic inflation. This concept, born in the minds of physicists in the early 1980s, suggests that the cosmos expanded at an unimaginable rate, ballooning from subatomic scales to astronomical proportions in a fraction of a second. But what sparked this theory, and why has it become a cornerstone of modern cosmology? The seeds of inflation were sown by puzzling observations. When scientists studied the cosmic microwave background, the faint afterglow of the Big Bang, they found the universe to be astonishingly smooth and uniform, with only the tiniest of temperature fluctuations. Yet, according to the standard Big Bang model, regions of space separated by vast distances should never have had time to interact or even know about each other. How, then, did the universe achieve such harmony? Cosmic inflation provides the answer. It posits that in the universe's first trillionth of a second, space itself expanded exponentially, stretching quantum fluctuations into the seeds of galaxies and smoothing out the cosmos like a freshly ironed sheet. This rapid growth explains not only the uniformity we observe, but also why the universe appears flat on the largest scales rather than curved or warped by gravity. Evidence for inflation comes from several cosmic clues. The patterns in the cosmic microwave background, mapped in exquisite detail by satellites like COBE, WMAP and Planck, match the predictions of inflationary models, showing subtle ripples that trace back to quantum fluctuations in the early universe. The large-scale distribution of galaxies, too, aligns with this explosive beginning, forming a cosmic web shaped by those primordial ripples. Inflation has reshaped our understanding of the cosmos, offering solutions to long-standing mysteries and raising profound new questions. What drove this burst of expansion? Was it triggered by a mysterious field now lost to time? Could inflation have happened more than once, spawning countless universes beyond our own? While the answers remain elusive, the concept of inflation reminds us that the universe's earliest moments were far more dynamic and strange than once imagined. As we gaze into the depths of space and time, cosmic inflation stands as a testament to the power of imagination and evidence working hand in hand. It is the story of the universe's first breath, a silent, staggering expansion that set the stage for everything that followed. Imagine tuning an old television set to a channel with no broadcast, just static, a faint hiss in the silence. In a way, that static is a whisper from the dawn of time. It's a relic of the cosmic microwave background, or CMB, the oldest light in the universe and one of the most profound discoveries in modern science. The CMB is not just a backdrop, it is the afterglow of the Big Bang itself, a snapshot of the universe when it was just 380,000 years old. At this moment, the cosmos had cooled enough for atoms to form, allowing light to travel freely for the first time. That ancient light, stretched by the expansion of space, now fills every corner of the sky as a faint uniform glow in the microwave part of the spectrum. Scientists first stumbled upon the CMB in 1965 when Arno Penzias and Robert Wilson detected an inexplicable background noise with their radio antenna. What they found was the lingering heat of creation, a discovery that would earn them the Nobel Prize and forever change our understanding of the cosmos. But the CMB is far from featureless. High-precision maps from satellites like COBE, WMAP and Planck reveal a tapestry of tiny fluctuations, minute differences in temperature, only millionths of a degree apart. These subtle ripples are cosmic fingerprints imprinted by quantum fluctuations during the universe's infancy and magnified by the process of inflation. What do these patterns tell us? They are the seeds from which all cosmic structure grew. Every galaxy, every star, every planet, including our own, can trace its origins to these primordial variations. The CMB also reveals the universe's age, composition, and even its geometry, allowing scientists to measure the proportions of dark matter, dark energy, and ordinary matter with remarkable precision. The near-perfect uniformity of the CMB confirms that the early universe was astonishingly smooth. Yet the tiny imperfections provided the scaffolding for everything we see today. It is a cosmic Rosetta Stone, a silent messenger from the past, helping us decode the story of creation. As we study the CMB, we peer into a time when the universe was young, hot and full of potential. Its faint glow is proof that we are, quite literally, made from the echoes of a cosmic beginning, a reminder that the universe's past is written in light, waiting for us to read. As the cosmic story unfolds, a lingering question drifts through the vastness: how will it all end? The universe, ever expanding and evolving, holds its ultimate fate as one of the greatest mysteries of existence. Scientists have envisioned several endings, each shaped by the delicate balance of cosmic forces and the unseen ingredients of reality. One possibility is the heat death, also known as the Big Freeze. In this scenario, the universe continues to expand forever. Galaxies drift further apart, stars exhaust their nuclear fuel, and new stars cease to form. Over trillions of years, matter is slowly pulled apart, and energy spreads so thin that all activity grinds to a halt. The cosmos becomes a dark, cold expanse, a silent sea of fading embers where time itself seems to lose meaning. Yet the universe's fate may not be so quiet. Enter the Big Rip. If dark energy, the mysterious force accelerating cosmic expansion, grows stronger over time, it could eventually overcome all other forces. Galaxies would be torn apart, then solar systems, planets, and finally atoms themselves. In this dramatic finale, the fabric of space and time is ripped asunder, and the universe ends not in silence, but in a final cataclysmic crescendo. But what if gravity, the great sculptor of the cosmos, eventually asserts dominance? The Big Crunch envisions a universe that halts its expansion and reverses course. Galaxies rush together, merging in a cosmic pile-up. Temperatures soar as matter collapses inward, culminating in a fiery implosion, a return to the dense, hot state from which everything began. Some theories even suggest this could spark a new cycle, a rebirth from the ashes of the old. Other possibilities, like the Big Bounce or the emergence of entirely new physics, linger at the edge of imagination. Each scenario is shaped by the interplay of dark energy, dark matter, and the fundamental laws that govern all things, forces we are only beginning to understand. Though the ultimate fate of the universe remains uncertain, these predictions are more than cosmic speculation. They are beacons, guiding the search for deeper truths. In pondering the universe's end, the cosmos invites us to contemplate not just beginnings and endings, but the eternal dance of creation and transformation, a story written in the silence between the stars.